Hello, my name is Craig Savage, but you can call me Doc, and welcome to another episode of my coffee series, where I, as a data science professional, find something of interest. In this case, it's something from LinkedIn, and I discuss it in an informal fashion, sitting here in my t-shirt, drinking my coffee. So if you'd like to join me in a cup of coffee or some other beverage, if you hit pause on the video, I'll wait for as long as you'd like. So today I have an interesting article by Cassie. I'll put the article up here. So here's the article. A few things to note about her. First of all, her title is Chief something. She's what I call a C-level executive, and she works for Google. So she works for a tech company. I don't work for a tech company. Most of the companies I consult for aren't tech companies, so our perspectives are very different, and I'd like to talk about that in the context of this article. Again, it was by Cassie. She includes many other of her loves in her tagline here, including puns. I think it's almost necessary that if you're in tech, you need to be good at puns, and by that I mean be terrible at puns. And I'd like to start at the bottom of the article because she saved the best for last, but I want to talk about it first. And under this, good luck and have fun, and I fully appreciate that. And if you're moving into data science, good luck and have fun. This should be fun. If it's not fun, maybe it's not the right place for you. So when it comes to applied machine learning, the hardest part is knowing what you want to cook and how you plan to check it before serving it to your customers. Bingo, this is the #1 problem I face as a data science professional, that people don't know what to cook. Again, this is an analogy, we'll cover it more later. And I find it a bit rich when she said that part is actually not that hard, just don't forget to do it. There's no other article there. This, again, is what I struggle with the most. And she might not find that it's actually that hard because she is a C-level executive. So if there's a question about what you're doing with your machine learning, how you're using it, she's a C-level executive. She can make the decision herself, or she has direct access to people with the authority to make these decisions. So for her, it may not seem that hard. But for me, as a grunt, coalface level consultant who gets brought in to solve these types of problems, this is, for me, the biggest problem. And she acknowledges that it's the most important problem, but for her it's not that hard. For me, it's very difficult. So we have a different perspective there. And it's the two parts, both what you're doing and when you've done it, how do you know it's right? As a consultant being brought in, frequently organizations don't have this type of capability, which is why they're hiring consultants. And so when I produce something, they don't know if I've done a good job. They don't know if it's actually what they want. They don't know if their data will support it going forward. It's a severe problem. And the other thing I'd like to talk about this article is she says, and before you fling your rotten tomato at me for finding such an incomplete caricature, no, I'm not flinging tomatoes. I just want to highlight differences as to why her experience might be different from mine, and some things for you to consider if you're looking at moving into data science. If you're going to a technology company, if you're moving into management in one of these companies, versus if you're going to be someone at the coalface working on this from the most basic level, the differences that you may have with respect to this article. It is a very good article. I don't want to talk about it in too much detail because I want you to go read it and come up with your own opinions. But she starts off by saying that when people talk about machine learning, it's like it's one thing. Actually, it's more than that, but we'll get to that. That there's the act of baking itself, and then there's designing what you're going to bake. So that's the two things that she covers of more and more here, that there's the people that are building microwaves and wiring microwaves, and then there are chefs. And if you're a chef, you shouldn't need to know exactly how a microwave works. And if you're building microwaves, you might not know the best about combining ingredients and what things taste good together, but you should respect what each one of them is doing, how they're going to be used, what their strengths and weaknesses are, etc. And she carries through that analogy quite well. And she has this image illustrating her point, that you go from data, which are like ingredients, algorithms, which are like appliances, models, which are like recipes, and then finally getting predictions from your models, which are like dishes. And she talks by saying she sees a lot of businesses getting into problems, that leaders try to start their kitchens by hiring folks who've been building microwaves their whole lives but have never cooked a thing. Again, this is where she and I have differences. For me, when I'm brought in to help an organization, frequently they have a young person who has some experience with machine learning or artificial intelligence. A lot of universities now have master's degrees in data science where they're learning how to use all these algorithms. They might not understand how they work, but with the number of R packages available, Microsoft has a machine learning suite that you can download for free. So there are all these machine learnings and artificial intelligence functions out there that you can load up your data, call the function, and get a machine learning answer back. Frequently young people will think that machine learning is just a collection of algorithms, and if you're using a neural network, then you're doing machine learning. I think that's a bit of a simplification, but at a high level, sure. So while she's saying that there are these people that have been building microwave parts, again, from her algorithm, from her analogy, there are people that are used to building algorithms. They've never cooked a thing, so they've never used those algorithms to build models and then create predictions. In my experience, it's the opposite. There are all these people that know how to make the function call an R, but they don't really know what's going on the back end. They just put their data in, get their predictions out, and go for it. And so she has this lovely image of people burning money, and she's saying that, well, who should you hire? You need an interdisciplinary team and leadership that understands this space. Again, she's quite privileged because she is leadership and she understands this space. So for her to say you need leadership that understands this space, well, she has that by default. She works for Google. This is what they do. If you're doing data science for an organization that isn't technology based, their leadership might have no idea what machine learning does. They might not know how to use models in the first place, and she says here that otherwise project fizzle will go nowhere. Leadership that understands this space is a huge point that at Google she probably doesn't understand. And as she's leadership herself, and she understands this is a problem, she understands this space, and she doesn't run this risk of projects fizzling and going nowhere. So I said earlier that she said that there are 2 points of machine learning, and actually there are more. Well, here she's spelling them out. So what's worth cooking and what the objectives are. Your decision makers and project managers. Again, she's one of these, so she has this by default. People who understand suppliers and their customers, domain experts and social scientists. So when you're building machine learning algorithms, what are they predicting? How are your customers going to react, etc.? This gets overlooked a lot, and I praise her for pointing out that this is something that's required. People who can process ingredients at scale, data engineers and analysts. People who can try many different ingredient appliance combinations to generate potential recipes, applied machine learning engineers. People who can check the quality of their recipes, statisticians. I'd also include validation in this type of space. People who can turn a potential recipe into millions of dishes served efficiently, for up to 6 things now. Software engineers, and of course if you're in a small company, maybe you don't need this, but there it is. People who can keep the interdisciplinary team on track, project program managers, and then people who ensure your dishes stay top-notch, even if the delivery truck brings you a ton of potatoes instead of the rice you ordered, so reliability engineers. So we're up to 8 different parts that would be needed in her example of a machine learning workflow. If you want to do this without machine learning, you can delete the applied machine learning engineers. If there is some existing process by which you're generating models, you can do all of this without the machine learning side. And in my opinion, the analogy still holds, that you're getting data. Your algorithms might be quite simple. It could be as simple as, well, give me the mean of what I got this month. Models, again, you take the mean, you look at the mean, you compare it to last month, for instance, and then some prediction. Well, if you're selling more things, if you're making these pizzas, and the pizza is like it was last month, then good. If you don't have this infrastructure, trying to inject machine learning into it can be very difficult. Some of the problems I see from consulting is companies don't have this set up and they want to start going with artificial intelligence, machine learning, but they aren't entirely sure what dishes they're making. The other problem I see is, from this analogy, if you're serving pizzas and they say they want better pizzas, okay, Do you want better ingredients? Do you want better appliances? Do you want better recipes? We can change any one of those things, but for the most part, they're going to require money. They're going to require investment. They're going to require you changing the way you're currently doing things in order to get better pizza, or better predictions in this case. And frequently the problem I have then is, no, we don't want to change any one of those previous steps. We don't want to make the investment in our people. We don't want to make any investment in our infrastructure. We just want better pizza. And okay, maybe if you get a better chef in her analogy, you can get better pizza. But from a data analytics point of view, if you have data, you have certain algorithms, you combine those algorithms into models, there's not much wiggle room. There's not a whole lot you can do. You might be able to present it better. You might be able to take the results and make prettier graphs or show how things could be adapted from a business context. But while there's skill in all these things, in her analogy of cooking, from the turn the handle, repeatable, mathematical exercise of machine learning, or even without machine learning, of turning data into predictions, there's not a lot of wiggle room. It's another area where I think her analogy sort of breaks down. But overall, yeah, I highly recommend the article. I highly recommend, if you're thinking about moving into data analytics, that you consider what she considers here to be decision intelligence. And she says that she has a team working to fix that. Again, her title is Chief Decision Officer? Chief Decision Intelligence Engineer. My apologies. She says that they're working on fixing that. Where is it? They've created the new discipline on the applied side, and they've trained 15,000 staff members in it. That's very good. They're calling it Decision Intelligence Engineering. It spans all the aspects of machine learning and data science. To put it another way, research machine learning is building microwaves, and applied machine learning is using microwaves. Decision intelligence engineering is using microwaves safely to meet your goals and using something else when you don't need a microwave. So that comes down to, don't put metal in the microwave, and if you're making pizza, maybe you don't make your pizza in the microwave, which I thought should be fairly common anyway. What do I mean by that? Well, if you've got these microwaves and you're not using them safely, you should figure that out pretty quickly. You know, if you don't know to not put metal in the microwave, or to not use some algorithm on bad data, for instance, you should get a pretty bad product. And if you're making a bad product and no one notices, there are bigger problems than whether or not you're making the right product and what algorithm you should be using. And I'd like to conclude with that finally, a lot of the stuff I do doesn't matter. That kind of hurts, but the number of reports I see, and you find that there's been a mistake in this report, and you're like, oh my goodness, I've made a mistake in this report, I need to fix it, I need to report it up the chain, that, oops, I'm so sorry, I sure hope no one's made some groundbreaking decision on incomplete or incorrect data because I made a mistake, darn it. And you find out that actually no one reads the report, and it's easy to correct. So that's where I'd like to leave it. Again, I do recommend going and reading the article. And Cassie, if you're watching this, no, I'm not meant to be throwing tomatoes at you or even tomatoes at you, but the perspectives from your level, the perspective of ground level data scientists, could be very different. So what do you think, everyone else? Are you in a situation like this where you've been asked to do data science that you think is incomplete or that you think is foolhardy? Have you looked at doing machine learning and you find that you need these other skills, that you find you need to have a better understanding of data? Do you think that her team here is appropriate? Have you been in situations where you've had a full team or that you've had an incomplete team? Have you run into any of these problems she's talking about? Thank you all for watching, and I'll see you next time at Real World Analytics in the Coffee series. Goodbye.